So, today's date, 11/14/17, right? So our topic today is going to be graphing quadratic inequalities using technology, but basically our calculus, or technology. It does sound, makes it sound cool if we say technology instead of calculator, right? All right, now, there's a few things we have to do that I consider just common sense. What I mean by that is, if we're going to put things in our calculator, I want you to look at the calculator, and you can't hardly see that, can you?
You might need a lighter one.
I just got to get it under the light. If I can get it under the light, that'll help. There we go. It's under the light. Almost under the light. I know I'm recording while I'm doing this, but I'm going to go like that. There we go. That's better, huh? So, when we take a look at the calculator, what I have is a window. Okay, right? I'm going to put the graph on the window. Let me show you a couple of easy examples. Now, I'm not going to push the windows, but I want you to watch, because it really makes a lot of sense as I go through this, okay? So let's take something you know, okay? Something really easy. Let's say we're going to graph y equals, say, x squared minus 4. Boom, boom. We know it looks something like this. Everybody agree with that? I mean, right? We agree with that? So here's what I know. I know this is down at -4, correct? Right? This is at -2 and 2. We don't even need to know all that. We just need to know that if we're going to put a window around this thing, we probably want to go from maybe, I don't know, -5 to 5. Does that make sense? Common sense, right? Common sense. Maybe, I don't know, -10 to 10, maybe. It's just common sense. Now, what you can do in your window is choose your window. So, let me, I want to do this wrong so you can see how important the window really is. So, if I go to my y equals, clear. Oh, I'm in the wrong mode. Let's change the mode to function. All right, y equals. So let's say I do my x squared minus 4. I just want to do it wrong. I just want you to watch. Don't want you to do anything. Just want you to watch, because I'm going to do it wrong. And if my window is on, like, let's say it is 100 to, say, 200, and maybe it's 50 to 1,000. Okay, so first of all, I'm on my graph going to be way out here and way up here. I'm going to graph it, boom, graph, and of course I'm not going to see my parabola at all, am I? It's graphing it right now, but we're not going to see it at all because it's not in the right window. So when we talk about the window, this is where we have to use a little bit of common sense, because well, what should be my window? And I might answer back and say, well, think about it. You're not going to like that answer, are you? So in this graph, let's go straight to our first example, okay? And we're going to go y equals, okay? So go to y equals and clear, okay? So everybody have y equals, right? You got y1. Does anybody not have this? Anybody not have this? Okay, and then the x variable, okay? The x variable is right there. That's my x variable. So I'm going to go x, okay? X. I'm going to go squared. My x variable is right there. X t theta n. X squared. My squared is right above that log. X squared. Square is right kitty corner from the 7. The square button's right there. Square button's like right.
Oh.
Yeah. Minus 2x subtract 8. Okay. Give me thumbs up. If you do not have this, raise your hand. If you don't have this, everybody have this? Yeah. Hang on to that. Okay, let me put back. Okay, yeah.
I tried to do that because I'm just going to change it when it's not working.
Hold on. Okay, let me keep going. Okay. So, you got that? Now, before we graph this thing, so the first thing we did, and we got to check the window. So I'm going to go to my window, and I mess with my window. But what do you think would be a decent window? I mean, we're going to graph this thing. Use some common sense. We're doing a parabola. What's a decent window for a parabola? From what to what on my x's? From what? What should be on x min be on my
You
x?
said 5 earlier.
Sure, -5 would work. You guys okay with -5? So if I go -5, negative 5, not subtract 5, but negative 5 to max. How far over am I going to go? How far over am I going to go? How far am I going? Negative 5 to what? 5. 5 will work. You guys agree with that? 5. It's just a matter of common sense, hopefully. Scales, I'm going by ones, right? I'm going by ones. Scales by ones. Why min? What do you think? Why min? I know negative, well, on this one, I don't know. Negative 10 is a great idea. Negative 10, I like negative 10. To a max, how high up do you think we should go? 10 maybe, okay. And scales by 1, okay. So then, if I push graph, hey, there it is. Now I can always adjust. If I wanted to pull it further down, I could change my y min, right? But I have it. Everybody have that?
Why does mine say error?
It could be the negative instead of subtract. I'll double check.
I suppose that's negative, right?
That's negative, yes. So let's go to it. Oh. Okay, hold on. X squared minus 2x or minus 8. Okay, try that graph. Okay, there it is. Okay, all right. Everybody have it? Now.
You're using the wrong mode.
Everybody have, if you don't have that, let me know.
Why isn't it?
Did you get it?
Yeah.
It did work.
Why are there lines for shading? This thing's
Yeah.
too advanced.
You didn't get it? You got it, okay. Now, you ready? So, real quickly, listen, here's something that you're really going to like, okay? Now, if we needed to find this value, by the way, what is this value called? Vertex. We had to do the negative b over 2a, right? And we also had to plug it in and get it right. Well, the calculator can get the answers for us. Of course it did. I just didn't want to tell you until now. So how can the calculator give us the vertex? It's easy. Let me ask you a super easy question. Is this a minimum or a maximum?
Minimum.
Great. So you're going to go to this button called Calc. It's in blue. So you're going to go straight to this button. It's in blue. So it's called Calc. It's up. Sorry. The calc is up by the trace. It's in blue, so you're going to go second calc, all right? So I'm going to go to second calc, all right? And I get a whole bunch of choices. Second calc. So hit the blue button, and then calc, which is right up here by the trace. I want this button right there, okay? Okay, everybody have it? Anybody not? Okay, what do we want to find? We've got a whole bunch of choices. What do we want to find? Minimum. Does that make sense? Because the vertex is the minimum. So if we're going to find the vertex, let's go straight down to my minimum, right? So go to minimum, because the vertex is a minimum, okay? Enter. Now, here's the thing. Watch, and it kind of makes sense. We haven't talked about these kind of graphs yet, but we will. We will talk about these kind of graphs someday, right? Has more than one, it has lots of minimums, doesn't it? So you have to tell the calculator where to look. So it says left bound. So I know that my minimum is here, right? So what I'm going to do is put a boundary over here and say look in here, because that's where the minimum is, right? So I need to tell the calculator where to look. So it's flashing right there. That's okay, but I can move the cursor back and forth. So I just need to be left of the point I want to find. Anywhere left of the point I want to find is fine. That's good enough for me. Okay, so I need to just be left of my vertex. So back and forth arrow to make sure that I'm going to tell it, I'm going to give it a region to look. Okay, so I move the arrow back and forth as long as I'm on the left-hand side of my vertex. So I push enter. See, I was blinking. I push enter. It locks it in. Right-hand bound. So I moved my cursor over until it's on the right-hand side of my vertex. Okay, there it is. Okay, it's blinking. Okay. As soon as I push enter, it locks it in. Now, the calculator knows to look in between here. So the calculator is now going to look for my vertex or my minimum right in here. Okay, so it says guess. So I'll go over, I think I would guess right about there. You don't have to guess. It's just the feature of the calculator. But I think it's right about there. Push enter and it's going to tell me exactly what it is. Boom, what do you know? It's at 1 and negative 9. Okay, do you see that? It's at 1 and negative 9. It's 1.007, but it really is 1 and negative 9. So my vertex, we didn't have to do the negative b over 2a, did we? There's the vertex. So my vertex is at 1, negative 9. Okay? Okay, now the y-intercept we know already, just simply because the y-intercept is the negative 8. You guys agree with that? The y-intercept is going to be at 0, negative 8, right? The x-intercepts, all right? Now there's two ways to get the x-intercepts. Personally for me, factoring is the fastest way, but the calculator can also get them. So I'll show you how to get the x-intercepts. So the x-intercepts are also called zeros. Okay, x-intercepts are also called zeros because it's where the graph has a height of 0. Okay, now real quick, how many zeros does it have? 2. Guys agree? So we're going to find both with the calculator. So okay, same thing. I'm going to go back to this button, calculate. Go back to that button, calculate. Okay, calculate. Okay, and there it is for 0. Okay, see the 0? Am I going too fast? I'm okay. Okay, so I highlight the 0. Now there's 2 of them, so I can only find one at a time. Enter. So 1, 0 says the left band. So let's try and tackle this 0 first. Okay. So I got to get left of this point, which is really above it. Does that make sense? Left of it is above it. So I'm just going to pull my cursor over.
You always have to go above?
Well, I just have to be left of it. That's the main thing. Left of it. In this case, left is above it. Do you agree? But I'm going to be a left. Well,
Oh,
it's
okay, because 0's, yeah.
yeah, okay, and it's blinking. Remember, I'm trying to tell the calculator where to look. It's blinking. I'm saying, okay, I want you to look here, so I'm going to push enter so it's locked as in. So I go to the other side of it. So now I'm saying look between these two areas. So now I've got my 0 locked in between these two areas. So push enter. So now I'm saying to the calculator, look in between here and here, and sure enough, you should find that 0, shouldn't you, right? So get this region and say look in here. So guess. Well, I think the 0 is right about there. Enter, and I'll tell you exactly what it is. Negative 2, 0, right? Which we could have gotten much faster by factoring, but here's how you could do it anyway, right? So if you can't factor, this would always work, right? So then we can go, hey, 1, 0 is at negative 2, 0, and then if I need the other 0, we'll do this whole darn thing all over again. So we're going to go to calculate. Let's find the other 0, because there are 2 zeros, okay? So
Can't you just tell by looking at it?
yes, I like that. You can tell because, mathematically you get a line of symmetry, don't you? Right? But sometimes you can't. Sometimes it's a decimal, right? That's why it's good to practice something easy. Okay, 0. I want to look at the other one, so I'm going to go to the right-hand side of it. So boom, move it over, move it over, move it over, move it over. Okay, I want the right-hand side of it. So I'm to the right of my 0, right? I'm to the right of this point right here. I am to the right of it.
That's nice.
No, I'm not. I'm on the left-hand side. Left-hand side, enter, right-hand side. Okay, so I'm on the right-hand side of it, enter. Now I'm telling the calculator, look for it between this region here, which will get that for me. Guess, enter, and there it is. Now, this 1.6 e to the negative 12 is 0. It really is 0. Because the calculator doesn't do math. It finds things, and it didn't exactly find it, but that is 0 because that's e to the negative 12. That is 0. So you've got a 4, comma 0. Okay. Now, we can graph this pretty easily from what we have, right? We can go to 1, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? I can go 0, negative 8, right? Negative 2, 0, and 1, 2, 3, 4, 0. And I'm going to go ahead and just sketch it in, okay? Everybody with me? Now, we could have done that doing the math that I've taught you, but, there it is graphing. Now, here's the thing we have to go back to, and I'm going to zoom this out now. No, I don't think I can when it's recording. But here's what we got to go back to. What we want to do is everything above, greater than the parabola. So think about this. Use a little common sense. It's greater than. Everything greater than the parabola would be above the parabola, right? So that's a lot of points. It's a lot of points. In fact, it's this point, it's this point, it's this. All these points are going to be above the parabola. So we're going to shade, right? So we just shade above. And there we have it right there. Now, of course there's a shading feature on our calculator. You want to see that? How it can shade also for us? Want to check it out? Okay. So then if I want to shade, I go to y equals, right? But if we can change our equal sign into a greater than sign, it'd be much better because it won't shade. So I'm going to go all the way over. See, right now it's on draw a straight line. That's what this symbol means. Right now it says draw a straight line. So I'm going to push enter. I'm going to get a bunch of features, okay? I get a dark, heavy line if I want a dark, heavy line. That is greater than because it's the triangle above. That is less than because it's the triangle below. That is a little dot, so you can do dot, 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 which is kind of cool. And that is more zeros. But what I really want, and that's like a faint little line, what I really want for greater than is that one. Do you guys see that? I want that one there. Because if it's up, triangle shade, it means greater than, shade above. And so if I push graph again, check it out. Am I going too fast? Want to see it? Did you push enter? It's cool, isn't it? It is pretty cool. Ready, set, enter. Oh, that is so cool. There it is, right? Shaded for you, right? Pretty slick. Now, I agree with what Megan said, that we can see our x-intercepts there, and there. We can see our shading there, okay? All right. Okay, thumbs up. We're going to practice this one more time. I'm going to stop the recording because I've done